Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Yin-Yang Whispers by Scruffa Muda. Um, I actually recorded a small video, a short video that I was trying to do before, and I realized that I messed up some of the rules, and I hadn't gotten very far in the puzzle, so I'm just redoing this because I understand now the rule set, and it makes a lot more sense actually this way. Anyways, here are the rules. We have normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. That is boxes here. We have Yin-Yang, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. So here's an example of a yin-yang shading that works. Because and no 2x2 region is entirely shaded or entirely unshaded. So if you try to go from any cell in the shaded region, you could just stay within the shaded region just by going through edges. And you could get to any other cell in the shaded region by doing this. Same with the unshaded region, right? You can go to the unshaded region and connect by doing that. Connect to any other cell in the unshaded region by just staying within the unshaded region by going through edges. And no 2x2 area in this entire 9x9 grid is entirely shaded or entirely unshaded. So that's yin-yang shading. We also have circles, where a digit in a circle must equal the length of the first run of shaded cells seen along the adjacent row or column. If no shaded cells appear, the length is equal to 0. Circles themselves are not part of the yin-yang shading, which makes sense because they're outside the grid. So, for example, this would see the first length is 1 here, right? Because the shading here is only just 1 in length. This would be 8 here because it sees 8 as a run. This is 1. This is 8. This would be 1, and this would be 1, right? This would be 8 because it sees the first run, and it counts how long that run is. So it would be 8. This would be 1 because it would count how long this run is. And this would be 8 because it would count how long this run is. If we had something like, let's try to make something that would, So let's go this way. Actually, yeah. Let's go this way. So if this were the yin-yang shading, this would actually be a 0 because it would see 0 shaded cells along the length of the rows, right? This would be 1 because, again, yeah, it's the first row of shaded cells that it sees. And if it doesn't see any, it's 0. That's part of, actually, I made 2 errors when I first read this, so I didn't actually understand either of these rules. This was the first thing that I got confused about because I thought it was just basically the length of basically it was the first amount of cells were essentially shaded, but that's not guaranteed. And that led to a contradiction pretty quickly, which was why I didn't get very far in the puzzle. So that's the first thing that I misunderstood. So again, it's the first run. So the digit in the circle counts the length of the first run of shaded digits, not necessarily guaranteeing that the first digits are shaded. Also, we have German whisper lines, where adjacent digits on a green line must differ by at least 5. And any digit greater than 5 on a green line must be shaded, excluding circles, right? Because circles are not part of the yin-yang shading. So, for example, if this were a 3, this would have to be an 8 or a 9. And the second part of what, because the digits that are 5 or more away from 3 are specifically 8 and 9. So the second part that I got confused about was that any digit greater than 5 on a green line must be shaded. But you can have shaded cells that are 5 or below on a green line. It's just that the digits that are greater than 5 have to be shaded. So we know guaranteed that those are shaded. So for example, if this were, say, like 3, 9, 2, 8, and 1, these two cells have to be shaded. But these two cells could also be shaded. We actually don't know, right? But you have to shade the cells that are greater than 5 on a German whisper line. So that's it's not a negative constraint, right? It's not that cells that are not greater than 5 are not shaded, but you need to just shade cells that are greater than 5 on a green line. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Again, for the second time, but I didn't really get far the first time because I didn't understand the rules. Anyways, let's go. Okay, so I don't actually know how many cells are shaded here. We know on this. Okay. So, okay, one thing actually that I did see, if we made this high, well, it's not true necessarily. If we made this high, a high digit, and this was a low digit, and this was a high digit, the problem is you have a guaranteed 6 cells which are shaded. So these 3, no matter what, would always be shaded. Same here. This would always be shaded too, because you have to have 6 cells in a row which are shaded somewhere, right? And if that's the case, this can always alternate shaded and unshaded, right? But these we are guaranteed to have shaded. And if that's the case, there's no combination of cells here which you can have shaded, unshaded, and shaded, which would let the unshaded portion be orthogonally connected to the rest of the unshaded cells, right? So if this is shaded, unshaded, shaded, that doesn't work. If we tried to make this unshaded and this shaded, this would be unshaded, but then this would have to be shaded, guaranteed, right? Because you always alternate between low and high digits. And the problem, okay, so you can't obviously have all of these be shaded because then you'd have a 2x2 region which doesn't have unshaded cells, and that's not allowed. You have every 2x2 region must have shaded and unshaded cells in them. So this can never be high, low, high. Therefore, this has to be the opposite. This must be essentially low. Let's go. This has to be low, high. I guess this could be 5, and you could go to 0 here. Except 5 can never be next to a digit on a German whisper line without a 0, right? So this can't be 5. If this were 5, this would never be greater than Yeah, and this can never be 5, right? Because, yeah, anything that connects to any part of the grid, 5 is never 5 away from, um, 5 is never 5 away from any digit from 1 through 9, right? The furthest you can get is 1 and 9, and those are 4 away from 5. So 5 can never be on a German whisper line next to another digit on the grid. So this could actually be 5. This could be 5. This has to be 0 through 4. So this can never be 0, right? Because this can't be 5. If this were 5, it would be next to another digit, which it would not be possible to be next to. So this is 0 through 4. This has to be 0 through 4. So this is 6 through 9. 6 through 9 has to be next to a low digit on the German whisper line. We're going to color those yellow since blue is now shaded. Blue is going to be the high, right? So this is high. This is low. These are low. This is high. This has to be high, low. This is low. This is high, low, and high. And again, these are highs. These are highs. These are lows. So this is 0 through 4. That means this must be a 6 through 9 then, right? Because it cannot, it could be 5. No, actually it could be 5 here. So this could be a 5 here. It's 5 through 9. We don't know which, though. Those have to be lows because they're next to a high digit in the grid. So this has to be high also. So this is 6 through 9 also. This doesn't actually have to be high. So we know these are shaded. We don't know about these, right? This has to be 6 through 9, so all of these are shaded. We know that for certain. Same with this. All of these are shaded because it must be 6 through 9. Because it has to be at least a 1 here. So this is 6 through 9. If you have 6 shaded in a row, anywhere they are, it has to be either here, 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 or here. And these 3 are shaded. So these 3 are shaded also. If this were all 3 shaded here, that would not work. So this must be 0 through 4. Because you can't have 6 shaded here, and because that would then form a 2x2 area, which would be all shaded. So this has to be low, which forces this to be high, which makes this a low. So this is shaded. And this is, well, we don't know. It's 0 through 4, right? And this could be shaded, but we don't know. So this is shaded, this is shaded. We don't have any information about these, though. This, there has to, okay, so this is shaded. Green we're gonna make as unshaded. Or we could just make the shading red, right? Let's just do that. This is gonna be confusing otherwise. So the shading's gonna be red. Let's make this. Yeah, it'll be easier that way. Okay, so these are both shaded, therefore this must be shaded here. Same, these are both shaded. This must be. Oh, frig. That's the reason why. Okay, let's make it yellow. Because otherwise I'm going to get really confused by this. Because I saw the shading and I'm like, oh, well, these have to be shaded, so this must be shaded, but we don't know. We don't know if this is shaded. These definitely guarantee have to be shaded, though. This is at most 0 through 4. So this cannot be full shading here. So that means on this edge of the grid, we guarantee that it must swap here somewhere. So it must go from shading to unshading somewhere here, because this is only 0 through 4, right? Same here. This is 0 through 4, so it must go through some swap of shading. But this one's more interesting, right? This is 6 through 9, so this has to be shaded also, right? Because of that. So therefore this must be shaded, because this is the first run of shaded cells that you see. Because of that, this must be shaded. These have to be high. Okay, so shading, we're going to mark there. The high digits we know are gonna be shaded, and the blue are essentially gonna be the low unshaded. The yellow are low, but they could be shaded or unshaded. The green are unshaded. And obviously the high digits on a German whisper line can only be shaded. So these are all shaded. This is definitely the first part that's shaded, so this has to be shaded also. So all of these are shaded. This could be shaded or this could be shaded. We don't know. This can never be 9. If this were 9, the problem is that all of this would be shaded, and then there would be a 2x2 region here. If any of these were unshaded, they wouldn't connect with the other unshaded cells in the grid. And if they're not unshaded, there's a 2x2 region which is all shaded. So this can never be 9. Actually, I don't even know if it can be. It could be 8. It could be 8. So these can never be 4. This is 3 at most, right? Because they have to be 5 away from 6, 7, or 8 here. So these 5 are shaded. We don't know where anything else is. These 5 have to be shaded for the same reason, right? And again, this can't be 9 because of the same reasoning there. This is 6, 7, 8. This is shaded, so these have to be shaded also, right? This is a low digit next to 2 high digits. This is a high digit next to 3 other low digits. So this must be 8 or 9 here. This is also next to 3 high digits. So it also must be 8 or 9. This is next to 2 unique digits on a German whisper line, and it must be high, but it cannot be 8 and 9 because of the 8, 9, 8, 9 pair in the column. So this is 7. It must be next to 1 and 2 specifically. Well, this can't be 1 or 2 because of the 1, 2 pair in the box, so this has to be at least 3. And it cannot be 4 because 4 would have to be next to at least a 9, and this can't be 9. So this must be 3, which makes this an 8. So this has to be 8 shaded. We don't... Okay, so since this is shaded, and this has to be shaded, then this has to be shaded here. So this is unshaded, and it's a low. So this is green. This is 8 or 9. This is 1 or 2. This cannot be 9 either for the same reasoning, right? If this is 9, then it would block off this region. So this has to be at most 8. This is 1, 2, or 3 here. This is 1, 2. This could be... right. This is in between 2 unique digits, which have to be on a German whisper line. This cannot be next to an 8. Or so this is next to an 8, so this is 1 or 2. We have 1, 2, or 3 here. This has to be next to at most an 8, so it cannot be 4. So this is 1, 2, or 3 also. This is 1 or 2, so this could be 6, 7, or 8 still. We don't know which. We have a 7 here. What are the remaining digits in box 4? We have 5, 6, 8, and 9, right? That's fine. This is a high digit, so this is 6, 7, 8, or 9. This is 1, 2, 3, 4 as a low. This blocks off here, so this has to be unshaded. And this is a shaded cell. So this must be unshaded also. This is shaded. So all of this, since all three of these are shaded, this must be unshaded. And it has to exit out, so it has to go that way. So these are all unshaded. This is definitely shaded, so this cannot be 0. It's at least 1. This cannot be a 2x2 area with all unshaded, so this is unshaded here, which means this is 1. So it could be 6 and then another 1. That's possible. So this is all shaded. This is unshaded, so this has to be shaded here. This must go down here. So this has to be 6. Because the shading length is 6. This is then a 1 to be 5 away from 6. This 1 eliminates 1 here, so that's 2, which means this cannot be 2 here. This is unshaded. This must connect somehow to here, so this must go down to there, so that's unshaded. There has to be some unshading this way, so it must go that way. We don't know which one of these it goes through. This is unshaded, so it has to be a low. So this is 1, 3, 4, which means this must be a high. And on German whisper lines, you'll always alternate between low digits and high digits, which are the digits 1 through 4 and 6 through 9, because 1 can only be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 and 9, 4 can only be next to 9. So if you have a low digit, which is 1 through 4, you'll always be next to a digit, which is 6 through 9, which is high. So this must be high. This has to be 6, 7, 8, or 9. Either any of those work. This is 1, 3, 4, 6, 7, 8, 9 here. So we know it changes here. Because it cannot be the full 9 shaded, or it could be 0, actually. So, if this is 0 in shade, if this were 1 in shading, it could not be anywhere here, right? Because the thing is, for this a shading or unshaded part to go here, that would break the shaded part into 2 areas. So the shading, this is for all yin-yang, right? If you try to basically make it so that you have more than 2 changes on the edges, it will break. Because then basically you'll break it in part into either 2 shaded areas with 1 unshaded area, or 2 unshaded areas with 1 shaded area. So this must be unshaded. So yes, all of these, this also has to be unshaded. Because if it weren't, then this would have to be shaded, which would mean all of this would have to be shaded. Otherwise, if none of this but then this would be 9, which is not possible. So this has to be all unshaded. This has to be unshaded. This has to be unshaded also. Yeah, because it's at most 0 through 3. So that means the unshading has to go all the way to here. And we know, actually, it cannot be greater than 5, therefore this must be a 5, which forces this to be 0. Therefore, there are no shaded cells here. So these are all unshaded. And then this could be shaded or unshaded, we don't know. This is all unshaded, so this is a low, which must be next to a high, which makes it be next to a low. So this will be blue. This will be blue. So we have, this is next to 2 unique digits on a German whisper line. This is next to 2 unique digits on a German whisper line. So it's 789, 789. And this has to be low. It has to be a 4, actually. We can't have a 1, 2, or 3 here. So this is a 4, which makes this a 9, which makes this an 8. Therefore, this is 7. This has to be next to a 1-2 pair in on German whisper line. So, and this has to be shaded then because of it's either 6, 7, or 8. This 1 eliminates 1 here, so this is 2. So this has to be 7 or 8 in size. Shading wise. Oh, this is these are all shaded. Since these are all shaded, this has to be unshaded because of the 2x2 area. Therefore, the first one it sees here is 1. So this has to be 1 here because the shading size is only 1 in length. This can't be 2. This can't be 2. It's a 1-3 pair. This has to be 7. This has to be at least 7. So it's 1, 2, 3, 4, 5, 6, and 7 in shading size. And this has to connect somehow. And since this shading is all there, these all have to be unshaded. So these are all unshaded. This is 7 in size because it has to be at least 5 away from 2. And therefore, this is the shading this way. Well, this must connect to the rest. Oh, it is connected here. Okay. This is 1, 1, 0. These are all shaded. These are all unshaded. This can't be 5 because of the 5 in the box. Sorry, in the column. The rest of box 1 is 6, 7, and 9. We have a 1, 2, 1, 2 pair here. This 8 eliminates 8 here, so this is 9, which means none of these can be 9. So, and 4 cannot be here. Therefore, this must be a 4 here, and this is a 5, 6, 8 triplet. Yeah, I kind of had this wrong, but yeah. So this is 4. That leaves in column 1, the rest of the digits are 6 through 9. In column 2, the rest of the digits are 4, 5, and 6 because we can't have a 1, 2, 3 or 7, 8, 9. So this is 4, 5, 6, which eliminates 4, 5, and 6 in the rest of the box. This is a 7, 8, 9 triplet, which eliminates 7, 8, 9 for the rest of the column. So this is 6. This can't be 6 here. This can't be 6 here. That leaves 1, 2, 3 here. Okay. This 4 eliminates 4 here and here. So we have a 1, 3 pair in row 5. That leaves 5 through 9 in the rest of the row. Okay. Okay, what about these? They're 5 away from each other, so you have a guaranteed 5 in one of these is shaded, right? What does that tell us? Not too much, actually. Hmm. Say we had a guaranteed 5 here, shaded, or more. Okay, this couldn't be 5. If this were shaded, it would have to be 6 at least, and it would have to be all of these, right? So say this was all shaded. This would have to be less than 6. It can't be 0. Right, because then you would have to have, well, maybe it could be 0. Actually, that kind of does work. So if it's 6 or more, this is shaded. Ah, okay, this can't be 6 or more. If this is 6 or more, the problem is this would have to be a... Oh, but this could be shaded. Never mind. The low digit could be shaded. I forgot about that. Yeah, yeah. This cannot be 9 here because of the 9 in the row. We know one of these two is guaranteed to be unshaded. One of these two is guaranteed to be unshaded because this 2x2 box already has 2 shaded here. And if it had 2 other shaded, that would not be allowed. So one of these has to be a low, at least. What's... Yeah, how could this... So this is already done here. The rest of box 2 has to be 3, 4, 5, 6, and 8. But this can't be 5. This is 3, 4, 5, 6, 8. This can't be 6. Interesting. Here we have a high and a low. So if we had low, high, well, low, high, low, this would have to be a 9. And so it would have, because it would have to have a 4 next to it. Okay. Right. Oops. I should have colored this. Okay. This can't be 9. These have to be 3, 4, 6, and 8. This is 3, 4, 5, and 8 in box 2. We know in column 5, either this is low, high, low, or this is high, low, high. If this is high, low, high, this low has to be next to 2 unique digits on a German whisper line. So it would have to be 1 through 3. Therefore, we can eliminate 1 through 3 in the rest of column 5. If this is low, high, low, this would then be 1 through 4 in both of these spots. This would be 9. So we could again eliminate 1 through 3 in the rest of column 5. So this can't be 3. This can't be 3. This can't be 3. This is 4 through 9. What else do we have? So we don't really know. Okay, one of these has to be a high. And shaded. So say this was high and shaded. Then this would have to be high and shaded. These would have to all be unshaded. This would have to be low, but it could still be shaded. And then, okay, so then this would be all unshaded, right? No, we wouldn't have to get, we just have to go here. We need some opening here. So one of these two is unshaded. We don't know which. This has to be unshaded. Because, so since this is unshaded, this has to be shaded, which would force this to be shaded here, right? Because if this is unshaded, it's a low, which makes that a high. This needs to get out somewhere, so it would have to be shaded since or unshaded. So this, since this is unshaded, this would be shaded. So then, yeah, this would be unshaded. This would have to be unshaded. Unshaded here, and this would, I guess, be shaded. Ah, and then this shaded area would not work. So this can never be shaded here. This has to be, or high, I should say. No, it can't be shaded. So this has to be unshaded here. So this is, yeah, this is how it works out if we tried to be shading. If we tried to have this as shaded, right? It has to go all the way around here. This becomes a 2x2 area here. Because this is shaded, because otherwise this yin-yang would break things apart then if it tried to be unshaded here, right? This would be its own separate area. So this has to be shaded. Since this is shaded, this is a 2x2 area where they're all shaded, so this would have to be unshaded, which would force this to be shaded because unshaded has to be low on a German whisper line, and therefore this must be high and it must be shaded. Same here, same here. That means this is shaded, this is shaded. You can't have an unshaded crossing across a shaded area because then, again, you would break the shaded area into two separate areas, which is not allowed. So it must be shaded here, which means this is unshaded to get here. This is 2x2 area, which has 3 shaded cells, so this must be unshaded. This unshaded must connect to the rest of the unshaded, and therefore this 2x2 area would have 3 unshaded cells, so this would be shaded, but then this shaded cell is not part of the is not part of all the shaded other cells, or it's not orthogonally connected to all the shaded cells. So this cannot be shaded then because of that. Therefore, we know this is unshaded, which forces this to be shaded. Okay. What happens if we make this shaded? If this is shaded, that forces this to be shaded also, which forces this to be unshaded to get around. Interesting. So either way, if this is shaded, again, we can't have this unshaded because then if this is shaded and this is unshaded, to connect, you're going to have to basically form an area which is not orthogonally connected to the rest. So if this is shaded, this has to connect somewhere to get to here. So this is unshaded. So either way, these have to be highs then. Because we tried this if it's shaded. If it's unshaded, obviously this is unshaded and cannot be a high digit. So it has to be 1 through 4. So this, no matter what, is a high digit. So we're guaranteed that this is a high, that this is high, these are low, and this has to be high then, also guaranteed. So these are 6 through 9. This is specifically 7, 8 through 9 because it's next to 2 unique digits on a German whisper line. This is 1 through 3. This is 6, 8, or 9 because it's a high digit. This is 1 through 4. This is 6 through 9, and this could be 1 through 4 here. So this, I don't think, can ever be... Right, these are 2 shaded digits. I guess it could be shaded this way. That is possible. That's possible too. One of these 2 digits is shaded at least. So, because it can't be both unshaded. So this must be shaded here. This is 6 in size. That's fine. Both of these could actually be shaded. Or it's unshaded. We don't know. One of these two. Oh, at least one of these two is unshaded. Wait, yeah, it can't be. No, okay. If one of these two is unshaded, again, you can't swap shaded and unshaded on the edges too many times. So if this were unshaded and this were shaded, that wouldn't work. This therefore has to be unshaded. Since this is unshaded, all the rest of this is unshaded, which forces this to be shaded because of the 2x2 area here. This has to go that way, therefore this shading is at most, it's 0, 1, or 2. We don't know. Therefore, this must be at least 5 to be 5 away from 0, 1, 2. This must be at least 6. So since it's at least 6, we know all of these are shaded. Since all of these are shaded, to get out here, it either goes out this way or it goes out this way. We're not sure which. Could be 6, cannot be 9, obviously. So it's 6, 7, or 8 here. This is 1. This 2 eliminates 2 here, so this is 1, which makes this a 2 here. This 1 eliminates 1 here, so this is 3. This is 1. 3 can only be next to 8 on a germinal spur line out of 6, 7, or 8. So this is 8, which means 8 cannot be here, 8 cannot be here or here. And this can't be 8 because of the 8 in the box. This is 1. It could still be next to 6, 7, 8, or 9. This can't be 8 anymore. So there has to be a 2 in one of these spots. If 2 is on the outside, it's 2, 4 around surrounding 9. If 2 is on the inside, this is 2 and it's surrounding... these two are lows. This is a low. Therefore, both of these cannot be lows, because we would have 5 lows in row 7 if that were the case. Therefore, one of these must be high, the other must be low. If this is 2, this has to be next to 7 and 9, so this would be 9 and this would be 7. If this is 2 highs, it would have to be, it could be 6 and 9 next to 1. One of these is low, one of these is high. If this is low, it has to get out somewhere, so it would have to go that way. So this is low. If it's high, this in this 2x2 area, you have 2 highs, so that's not allowed. Sorry, you have 3 highs, and you can't have another high, so this would have to be low. So either way, this is a low. We know that for certain. To get out, then, it could be... It cannot go out this way, because one of these has to be a high, because we don't have enough lows here. We have 2 low digits here, that's a low digit, so only one of these 2 is low. And one of them does have to be low, so that eliminates low from the rest of the column. This is 5 through 9, this is 5 through 9. So this low cannot go out this way, it must go out this way then. So this must be low, or sorry, unshaded. To go out, yeah. One of these must be unshaded, I should say, and one of them must be shaded. It must go out this way, so one of these two has to be unshaded and the other one is shaded. And we don't know which one's which. This is 0, 1, or 2. If this is shaded here as 2, the problem is all of these would have to be shaded because you can't have it unshaded go here, right? So this cannot be 2. This has to be 0, 1. So therefore, it cannot block off this way. So it has to be unshaded here. This could be unshaded or shaded. We're not sure which. This cannot go out this way. So this has to go out this way then. So it has to go this way. This is 0 then. This is 5 to be 5 away from 0. This has to be, well, it has to be at least this. So this is connected that way. This has to be unshaded then to connect this part. So this is 7 in size. This can't be 5. This can't be 1. So this can't be 6 here. Okay. So one of these is shaded, one of these is unshaded. We're not sure which is which. We don't know if this is shaded or unshaded either. One of these is a high, but we don't know which. If we have 2 lows, so this can't be 1, 2, or 3 here. If this is 2 lows, this has to be a 4, which would force this to be 9. One of these is a low. So if it's low, it's 1 or 3 here, because it's in between 2 unique digits on a German whisper line, so it can't be 4. So we know this is a 4 then, because we have a low here, but none of them are 4. One of these is low. Otherwise, you have a 2x2 area, which is all shaded. Therefore, this has to be a 4, because that's the only place 4 can be left. So this is 4, which forces this to be 9. This can't be 9. Actually, this can't be 9. So we have a 9 and a 7, 8 pair in row 8, which eliminates 7 and 8 in the rest of the row. This can't be 7. This must be a 2 or 4 and is a low. So this has to be a high, which forces this to be 9, which is next to 2 or 4. This 9 then means this can't be 9. This must be the high. This must be low. So it's not. And therefore this, since these are already 3 shaded areas, this must be unshaded. So this must be unshaded too. So this is 1, 2, or 3. This must be a high, and this must be high. Well, the problem though is this can't be 7, 8, or 9. So this must be a 6, which makes this a 1. This cannot be 6, 7, or 8, so this must be 9 here, which means this can't be 9. This can't be 1 here. This can't be 1. This 2, 3 pair can only be next to 8 out of 6 or 8. So this is 8, which makes this 7, which makes this 8. This 8 eliminates 8 here, so this must be an 8 here, which eliminates 8 in the rest of the row. This can't be 7 because of the 7 in the column. The 7 can only be next to 1 and 2 on a German whisper line, so this is 2. This is 1. This can't be 7 or 9. It's 6 or 8. This can't be 9. No, 9 or 8, so this is 7. This can't be 7 or 8, so it's 9. This can't be 7 then, because it's 5, 6, or 8. This 2 eliminates 2 here, so this is 3. These can't be 3. This can't be 1 because of the 1 in the row, so this is 2. This is 1. This can't be 4. The 2, 4 pair eliminates 2 and 4 in the rest of the column, so this is 5. This is 6. This can't be 5, 6, or 9, so this is 7. This can't be 5 here, so this must not be, this can't be 6. We can't have 5 or 6 in the rest of box 2 because of the 5, 6 in the box. This can't be 9 or 6. This can't be 9 because of the 9 in the box. So 9 has to be one of these two. Remaining digits in box 8 or box 9 are 3, 6, and 8. 6 and 8 cannot be here. So this must be 3, which means this can't be 3 in box 9. 2, 4, 2, 4. This 6 eliminates 6 here. The remaining digits in row 8 are 2, 4, and 5. Remaining digits in row 9 are 3, 4, 6, 8. Well, no 6. 3, 4, and 8. So 5 in box 8 has to be one of these two cells, which eliminates 5 in the rest of the column. So this can't be 5. This is 6 or 7. And the rest is actually really just Sudoku. The remaining digits in row 2 are 3, 5, and 6. This can't be 3 or 5 because the 3 or 5 in the column, so this is 6, which forces this to be a 3, 5 pair. The 6 eliminates 6 here, so this is 8, which makes this 5, which makes that 6, which makes this 4, which makes that 5. This can't be 5 because of... This can't be 5 because of the 5 in the row. So this is a 2, 4 pair, which eliminates 2 and 4 in the rest of the row. This 8 eliminates 8 here, so this is 6. We have a 3, 4, 8 triplet in column 4, which eliminates 3, 4, and 8 in the rest of the column. This can't be 4, so this is 2, which makes this 4, which makes that a 2. We also have what's remaining? 1, 6, and 7. Yeah, 1, 6, and 7 in column 4, which means we have a 1, 6, 7 triplet. Actually, we have a 6, 7 pair, which eliminates 6, 7 in the rest of the box. So this is 1. This 6, 7 also eliminates 7 here, so it's 5. This can't be 5. We have the remaining digit as a 4. This is a 4. The 7 eliminates 7 here. 6, which makes it 7. 6 eliminates 6 here. It's 5 and 6. This has to be a 6, 9 pair here. This 6 eliminates 6 here, so this is 9, which makes that a 6. This can't be 4 because of the 4 here. The remaining digits in row 4 are 2, 5, and 7. This can't be 2 or 7 because of the 2 or 7 in the column, so this is 5. This becomes a 2, 7 pair. This 5 eliminates 5 here, so it's 3 and 5. Okay. In column 4, we are missing 4 and 9. Okay. In column... Okay, so this is column... row 6. We're missing 3, which cannot be here, so this must be 3 and 4. So this is 4. In column 8, we're missing 2, 7, or 8. And this cannot be 2, so this is 7 or 8. In column... Okay, so this is actually a blue, but whatever. In column 9, we're missing 1, 2, and 7. Okay. And this can't be 2. Oh. How long is this? Wait, this is 5. That doesn't work. Ooh, we have a problem here. Ooh, cannot be... This has to be at least 6. Ooh, oh, wait, no. Okay, so this is... Oh, I messed up. Let's go back. Ugh. That was... No, I don't know how I did that. That was pretty bad. That was a pretty bad assumption. I was wondering how we were just gonna disambiguate. Okay, that was pretty bad. I had everything else done well, and I don't know why I assumed that had to be 7. I don't know why this digit I assumed to be 7. That's incorrect. This could be 5. I don't know why I did that. This has to be at least 6, so we know that's there. So then this is... this actually has to be 7. Therefore, this to go out this way, it has to go out this way, which makes this a 5. I don't know why I messed that up that badly. Anyways, this is 7, so it can't be next to 3 on a German whisper line. So this is 1, this is 3. None of these can be 3. I think this logic still holds, right? This can't be 4. So this 1 or 3, therefore this is 4, this is 9. 9 eliminates 9 here. This is a 7-8 pair, right? Which eliminates 7 and 8 from the rest of the rows. This can't be 7. This is 2 or 4 next to a 9, which is next to 2 or 4. So this is shaded, which means this is unshaded. So these have to be low shaded here. This is unshaded. This is unshaded. And this must be 1 or 3 here, which is next to, this is a high digit. This has to be a 6 because it can't be 7, 8, or 9. So this is 6, which makes this 1, which makes this no 6, 7, or 8 because of the 6 or 7 in the column and the 8 in the box. So this is 9. Okay, so this is still the same. This can't be 1. This can't be 1. This can't be 9. This has to be an 8 because 2 and 3 cannot make next to 6 on a German whisper line. That forces this to be 7, which makes this 8. Yeah, so all of the rest of this is pretty similar. Actually, I think it's almost all the same because all the Sudoku still works, right? This is next to 7 and 8, can't be 3, so this is 2, which makes this a 3. Yeah, so all of this is still the same here. This can't be 6, this can't be 4, this can't be 4, so this is 5 and 6 here, which eliminates 5 here. This is a 4-8 pair, which eliminates 4 and 8 here. This can't be 6, so it's 3. This has to be a 1 to be next to a 7. That's not a 2. This can't be 8 here. 8 cannot be here, so 8 has to be here. Yep, this is all the same. This can't be 7 or 9. This can't be 7 or 9. This cannot be higher than 6, otherwise it would be shaded. Sorry, it can't be 6 or higher, or it would be shaded. So this is 5, which means this can't be 5. This can't be 5, 6, or 9, so this is a 7 here, which means this can't be 7 here. This can't be 7 or 8 or 9, so this is 7. This can't be 7 or 8, so this is 9. This can't be 5. Okay. This can't be 7. This can't be 9 here. This can't be 6 or 7, so this is a 5, which means this can't be 5. This can't be 5. This is 3, 6, or 8, but this can't be 6 or 8, so this is 3. This is 6 or 8 here, 6 or 8 here. This 3 cannot be either of these. This 1 eliminates 1 here, so it's 2. This is 1. This can't be 6. We have 2, 4, and 5 here. 5 cannot be here. 5 has to be one of these two. It's fine. We had, what, 3, 4, 6, and 8 here. This can't be 3, so this must be 3. This can't be 6. So this is 4 and 8. We have a 4, 8, 4, 8 pair still. That eliminates 4 and 8 in the rest of the column. So this is a 5. This can't be 5 or 4. So this must be 2, which makes this 4, which makes that 2. Yeah, so the rest of this was all the same. I just messed up this coloring. Apologies for that. 4, 8, 4, 8 pair forces a 1, 6, 7 triplet. This has to be 6 because this can't be 1 or 7. That forces this to be 7. This is 1. This is 4. That makes this 8, which makes this 4, which makes this 8, which makes that 6, 8. 5 eliminates 5 here. It's 6, 4, 5. 6 eliminates 6 here. It's 5 and 6. This can't be 7. This is 6 or 9. Actually, I think this is different. I feel. No, it's not. 3, 5, and 6. Okay, never mind. 3, 5, and 6, because this is 3, 5, 6 remaining, and 3, 5 can't be here. This must be a 3, 5 pair. 6 eliminates 6 here. It's 9 and 6. We have 3 and 4 remaining in row 6. So this can't be 3. This is 4. This is 3. We have 2, 5, 7 remaining in row 4. This can't be 2 or 7, so this is 5. This is a 2, 7 pair. The 5 eliminates 5 here, so it's 3 and 5 here. We have 4 and 9 here. This can't be 4, so this is 9, which makes this 7, which makes this 9. This is 4 then. 2 has to be one of these, 1 and 2. This can't be 1, so this must be 2, which makes that 1. 2 eliminates 2 here, 7 and 2, which forces this to be 7 and that to be 8. Apologies for that mistake. Yeah, I wouldn't consider this hard. The logic actually kind of makes sense throughout, right? It's in between, I would say, challenging and hard for me. Really, the hard part was the coloring aspect. It was hard getting to get the red and then get the blue. Even though that the blue, yeah. Not having the blue was a little, threw me off a little bit, but... Yeah, I don't know why I made that assumption this had to be 7. That was just, I don't know, it's just straight wrong. This obviously had to be the 7. I don't know. That was just weird. I don't know why I did that. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.